Hello everyone, Dr. Abhishek Dhar here. Through today's lecture, I will try to solve the previous year questions of the ISC exam of the chapter Alcohol and Phenol. I have tried to cover almost last 14-15 years of questions which have been asked in the ISC exams, and from these particular video you can get 100% detailed idea about the ISC exam pattern for this particular chapter. And I'm sure if you can practice the question in a proper way with logic, definitely you can score full marks in this chapter by solving these questions properly, not in the ISC exam but CBSC and West Bengal Council of Higher Secondary Education Board as well for this particular chapter, alcohol and phenol, because there are almost 24-5 questions, and it covers up almost the entire important reactions of these chapter alcohol and phenol. So, and this will also be very beneficial for the students who are very serious towards their competitive exam like JEE and NEET, because through this video you can get a chance to very quickly recap the basic concepts of this particular chapter alcohol and phenol in a very short while. So we are starting with 1 marks of questions which have been asked in these ISC exams previous years. So question 1 says, haloform reaction does not take place with which of the following compounds? Propanone, 2-propanol, ethanol and methanol. This is a very straight and naive sort of question. At first you have to write down all the structures. So let's solve propanone, this one. So this contains ketomethyl group directly attached with carbon. So it will respond to haloform test. Then 2-propanol, this one, CH3CHOH group, this is directly attached to carbon, this will also respond to haloform. Then ethanol, ethanol contains CH3CHOH group directly attached with hydrogen atom, so it will respond to haloform test. Next, methanol, it has neither ketomethyl group nor CH3CHOH group, so of course methanol will not respond to haloform reaction. Option D is the correct answer. Next, we'll move to question 2. A mixture of concentrated HCl and anhydrous ZnCl2 is called dash. This is nothing but Lucas reagent, which shows maximum reactivity with dash alcohol. Means it has been asked that what is the degree of that alcohol, as it proceeds via SN1 reaction, so stability of carbocation is the considering factor over there, so 3-degree alcohol will be the answer. Next, how will you obtain the following? Give balanced chemical equation. Propan 2-ol from Grignard reagent. Propan 2-ol we have to prepare. Propan 2-ol, that means CH3 CH OH CH3 by using Grignard reagent. Okay, so if this is basically a 2-degree alcohol, so when a 2-degree alcohol we have to obtain, when acetaldehyde, means any aldehyde except formaldehyde, when reacts with Grignard reagent, it forms 2-degree alcohol. So here we have to take one aldehyde for the preparation and one Grignard reagent. So the corresponding aldehyde will be CH3CHO. So when it reacts with CH3MgBr, it will produce CH3CH CH3OMgBr. Then acidic hydrolysis will be done to produce the corresponding 2-degree alcohol. So this is the method. This was question 6. This was question 6. Next, we'll move to question 7. Why do alcohols possess higher boiling points as compared to those of the corresponding alkanes? So, alcohol, you write in this way: due to presence of acidic H atom can form intermolecular H bond. As a result, the effective molecular weight of alcohol increases. So, boiling point of alcohol becomes higher. In the next para, you write the second reason: as alcohol is more polar, and alkanes are non-polar, that's why due to stronger dipole-dipole interaction, the boiling point of alcohol becomes higher than its corresponding alkane. Hope you have got it. This is a question which belongs to GOC, what I think. This general organic chemistry concept. We'll move to question 8. This is again explanation short of. Glycerol is more viscous than ethylene glycol. Okay. So question 8 we are going to solve. Glycerol is this one. And ethylene glycol is this one. So in case of glycerol, 3 acidic H atoms are there. In case of ethylene glycol, 2 acidic H atoms. So, due to presence of higher number of acidic H atoms, here extent of inter and intramolecular H bonding is higher. Now one thing you have to remember, higher the extent of H bonding, higher will be the viscosity. That's why this is more viscous due to its higher extent of H bonding. Next we'll move to question 9. When acetaldehyde is treated with Grignard reagent followed by hydrolysis, the product formed is aldehyde. When reacts with Grignard, any aldehyde except formaldehyde, it produces nothing but secondary alcohol. So B is the correct answer. Next we'll move to question 10. How can the following conversion be brought about? Glycerol to formic acid. So actually this is the question what I think, this is a method glycerol to formic acid, because this belongs to uh, carboxylic acid chapter. It requires some different concept to make it. So I think this can be done later way. Glycerol to formic acid. This actually belongs to carboxylic acid chapter basically. Because you have to know some reactions and concept about the acid. So I think if this chapter is not properly done, you cannot understand the reaction. So we'll discuss later when I will solve the PYQs of the formic acid, the carboxylic acid chapter. So next we'll move to question 11. Complete the following statement by selecting the correct alternative from the choices given below. The compound which is optically active. Optically active means the compound must contain chiral carbon. 1-butanol, we have to draw the structure. This is 1-butanol. You see, no chiral carbon atom is present over there. So it cannot be optically active. Next, 2-butanol. This is the structure of 2-butanol. You focus on these carbon and see 4 different groups, 1 hydrogen, 1 methyl, 1 OH, and 1 ethyl is attached to this carbon atom. So this is chiral carbon. So this compound is optically active. Next, we'll move to question 12. Name the type of isomerism exhibited by the following pairs of compounds: 1-butanol and 2-methyl, 1-propanol. So we have to draw the structure. 1-butanol, this one, and 2-methyl, 1-propanol. So these two compounds, so they are asking which sort of isomerism is shown by these two compounds. So you see the structure of the chain is different. So nothing else is different. Everything is same. Functional group is same. Degree of the functional group, that means position, is same. So only chain length, structure of the chain is different. This is a straight chain and this is branch chain. So they are chain isomers to each other. Chain isomerism they will show. Next, give balanced equation for the following reaction: 1-butanol and hydrogen chloride. Okay, this is question 13. This is 1-butanol. When it reacts with HCl, OH2 plus, this carbocation and water is formed. This is 1 degree carbocation, unstable 1,2 hydride shift will take place to produce more stable 2 degree carbocation, and then the remaining Cl minus attack into it. So what will be the product and balanced equation? CH3 CH2 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 OH plus HCl gives So question 13 is done. Next we'll move to question 14. This is an example of trihydric alcohol and this is an example of dihydric alcohol. This was a question, but I think the options were given in a list, and from there you have to pick up the correct option to fill the blank. But mostly they asked, I guess, trihydric alcohol commonly used, which is included in your syllabus, is glycerol. This one, glycerol, CH2OH, CHOH, CH2OH. And dihydric alcohol is ethylene glycol. Ethylene glycol, its structure is CH2OH, CH2OH. Give balanced equation for the following. Glycerol is heated with oxalic acid. Okay. And glycerol this is glycerol and this is oxalic acid. When it is heated at 110 degrees Celsius, it produces formic acid, carbon dioxide and water. So from these you can also, as I have done over it, so you can do the conversion by using the same concept. What Here has been asked glycerol to formic acid. So this one is glycerol, this is formic acid. So if you heat glycerol with oxalic acid at 110 degrees Celsius, you will get formic acid. So you write down the same reaction over here, glycerol plus oxalic acid at 110 degrees Celsius, it will produce formic acid. This will be the exact reaction. So this problem is solved over here. You don't have to wait for the carboxylic acid chapter. Okay. Next, draw a pair of isomers for C4H10O and name the type of isomerism. C4H10O, different type of isomerisms can be shown by it, but most common we can think in this way: CH3 these two isomers functional groups are different. Here alcoholic functional group, there, here ether. So these two are functional group isomers to each other, functional group isomers. Another different type of isomers also can be done. So for practice, you try to draw the structures of the other isomers, positional isomers, or branch shot of isomer. If it is possible, you can check. Next question. It is not possible to solve over here because the blank should be filled from a given list, but the list is absent in the question paper here, so we cannot solve it. Perhaps it will be alcohol, and one alcohol will be there and one ether will be there. Right, next, write chemical equation for the given reaction, name the main product. Oxalic acid with glycerol at 260 degree Celsius. So oxalic acid, glycerol at 260 degrees Celsius, it will again produce the same thing, formic acid, and water and carbon dioxide, because here high temperature, in this high temperature, the product will not be changed. The reaction will be much more faster, that will be the change, but the product will remain the same. This will be the product. Formic acid will be formed along with water and carbon dioxide. Next, give balanced chemical equations when ethyl alcohol is treated with thionyl chloride. Okay. CH3 CH2OH when it reacts with SOCl2, it forms CH3 CH2Cl plus SO2 gaseous plus HCl gaseous. This is the balanced equation. Done. Next, give one chemical test to distinguish between the following pair of compounds: propan 1-ol and propan 2-ol. This is very common test. This is propan 1-ol and this is propan 2-ol. So you see propan 2-ol contains CH3CHOH group directly attached with carbon. So haloform test will be done over here. I2 dilute NaOH, CHI3. Yellow sweet smelling crystal of iodoform will be produced over here. But in case of 1 propanol, in presence of the same reagent, we will not get any crystal, no crystal. So thus, with the help of iodoform test, we can easily distinguish these two compounds. Next, we'll move to question 20. First question, write chemical equation to illustrate the following name reaction. Esterification reaction. Okay, so question 20. Now carboxylic acid RCOOH reacts with an alcohol in presence of acid to form ester and water. As here ester is being produced, so this reaction is referred as esterification reaction. Next, we'll move to question 21. Chemically distinguish between chemically distinguish between question 21, ethyl alcohol and sec propyl alcohol. Okay, ethyl alcohol is this one, ethanol. Sec propyl alcohol means 2-propanol. That is sec propyl alcohol. So this is, you see, 1 degree alcohol, this is 2 degree alcohol. Both the alcohols will respond to iodoform test. So we cannot distinguish between them by applying iodoform test. But here if we use Lucas reagent, as it is 1 degree alcohol, no turbidity appears. But here when it is treated with Lucas reagent, the solution will be turbid after 5 minutes, appears after 5 minutes. Thus we can distinguish between these two compounds. Next, we'll move to question 22. Asking for name the 2 organic compounds which have the same molecular formula C2H6O. Will they react with PCl5? The products forms. Okay. C2H22, C2H6O, 2 compounds. Yes, 2 functional group isomer we can get. One is alcohol, another one is ether. So when it is treated with PCl5, this one, and when it is treated with PCl5, you think this PCl5 in this fashion, PCl3 plus Cl plus Cl. So one Cl will be attached with it one Cl will be attached with it, and PCl3 will take up this oxygen. So what we will get, 2 moles of CH3Cl along with 1 mole of POCl3. This reaction belongs to the chapter ether. Next, question 23 will move on. How is iodoform prepared from ethanol? Give the balanced equation. Iodoform dilute NaOH when it is treated with CHI3 will be formed, and the side product will be sodium formate, because in presence of iodine, at first this alcohol will be oxidized to CH3CHO, and that CH3CHO basically finally take part to iodoform test. So CH3CHO, when you react CH3CHO with I2 and dilute NaOH, you will find that the side product will be sodium formate. So that's why here we are getting sodium formate as the side product. So this question is done. Next we'll move to question 24. Ethanol and 2-propanol chemically distinguished between. The same question, ethanol and 2-propanol. Okay, this is this one is ethanol and this one is 2-propanol. We can do it by applying Lucas test. It is done. Next, carry out the following conversion: ethanol to acetone. This is ethanol and this is acetone. So at first ethanol is treated with PCC and CH2Cl2, CH3CHO. Next it is further treated with CH3MgBr along with H3O plus. Then it is again oxidized by mild oxidizing agent to give this product. Next, 2-propanol to acetooxime. this one is 2-propanol. When it is treated with PCC-CH2Cl2, it will be oxidized to corresponding ketone, and when it reacts with hydroxylamine, a condensation reaction will happen to form corresponding acetooxime. This is referred as acetooxime because this is the oxime of acetone. Next, give one good chemical test to distinguish between the following pair of compounds, 1-propanol and 2-propanol. So you can distinguish it easily by performing iodoform test. 2-propanol will respond to iodoform test, but 1-propanol will not. Next, how will you bring about the following conversion, diethyl ether to ethanol? This is diethyl ether. When it reacts with HI, it will produce ethanol 1 mole of. Well, that's all for the video. This is basically initially what I have told, that this is a question paper which covers alcohol and phenol, but I have mistaken that, because in this video we have only covered the questions from alcohols, not from phenols. In the next video you will get the questions of previous years from ISC board and CBSC board from phenol chapter as well. So hope we have done enough practice of questions through this video, and if you can practice it in a proper way, obviously your skill will be enhanced in this particular chapter. Thank you for watching. Keep supporting Talanta, keep spreading good words about us, and if you are new to our channel, don't forget to subscribe us. Signing off for right now. See you soon in the next video.